This is the screencast for example 5, section 5.2. We're going to work from both sides. Sometimes you get part of the way through a proof and you don't know where to go from there, but the other side might give you a clue as to where to start, and I'll show you what I mean in a minute. I'm going to start with the left side in this example because because there's a fraction, and on the right side there's not a fraction, and I think it's easier to simplify things than to create a fraction out of just a one-line expression. So on the left side, I see we have 1 plus cosecant of u, and I know that cotangent is cosecant squared minus 1. So I'm actually going to take cotangent squared of u, leave that in the numerator. In the denominator, I'm going to change this to cosecant of u plus 1 so that I can create a difference of squares that's going to help me out. Cosecant of u minus 1 is going to get multiplied to both the numerator and denominator to create that difference of squares. So now in the numerator I have cotangent squared of u times cosecant of u minus 1, and then in the denominator I have my difference of squares cosecant squared u minus 1, which is cotangent squared. So if I rewrite that, cosecant of u minus 1, I can easily see and show my grader that cotangent squareds cancel, and now all of a sudden I'm with a very simple expression that doesn't have any obvious next step. I don't really know what to do. So off to the side, I'm going to try working from the other side just as some scratch work. So I'm going to take cotangent of u times secant of u minus tangent of u, and I'm going to change that to sines and cosines. So that's cosine of u over sine of u times 1 over cosine of u minus sine u over cosine u. Now, if I distribute this in, let's see, I would get cosine of u, so I'm distributing in here to each term, cosine of u over sine of u cosine of u minus cosine of u sine of u all over sine of u cosine of u. So now this is 1 over sine of u minus 1, which is cosecant of u minus 1. Exactly where I left off in actually carrying through my proof. Now my scratch work is going to help me finish the rest of the proof. This is where I started. This will be the first step I write down, second, third, and then finally my fourth step. So cosecant of u minus 1, I'm going to then change to 1 over sine of u minus 1. Then from there I'm going to unsimplify 1 over sine of u to cosine of u over sine of u cosine of u minus, and now I'm going to give this guy cosine of u sine of u over sine of u cosine of u, which is still 1, but it's just unsimplified to a point that's going to help me with my next step. So my next step, instead of distributing in like I did in my scratch work, I'm actually going to factor out the cosine over sine. So my next step will look like this one here, cosine of u over sine of u times 1 over cosine of u minus sine of u over cosine of u. I'll move that down here actually. And then my final step will be cosine of u over sine of u, which is cotangent of u times secant u minus tangent of u. So all along this proof, I've kind of been keeping the end in mind, trying to simplify, but I got so simple that I didn't know where to go from here. So if I started from the other side, and try and get to that same middle spot, I can work my scratch work backwards to finish off the proof. Now sometimes you might be able to do that in your head, like you'll see in my next example, and you don't need to do side work, but the side work does help. Then now try problem number 41. Sine squared times cosine cubed equals sine squared x minus sine to the fourth x times cosine of x. So I'm going to pick to work with the left side first. Again, this is totally up to you, but I'm going to pick the left side first. Sine squared times cosine cubed. So I'm thinking to myself, I need a subtraction on this left-hand side because the end has subtraction. And I also see that there is a plain old cosine there when there is a cosine cubed here. So I'm going to split, so I'm using the end to help me out with my work to start out with. But in this case, I don't really need side work. I can just say, I'm going to stick with the sine squared of x, and then I'm going to take a cosine cubed and split that into cosine squared times cosine of x. Again, I need this subtraction. So sine squared of x, I'm going to change cosine squared into 1 minus sine squared. Now sine squared can get distributed, so sine squared of x minus sine to the fourth of x, cosine of x, is exactly what I wanted. So this one was a little bit easier than the last example, but it still demonstrated how to keep the end result in mind. This next one, I am definitely going to do work off to the side. Look how complicated this is. There's a's, b's, sines, cosines, tangents. Oy, what a mess. So I'm going to work with the left side, actually. I know before I said the right side has tangents, and tangents are sine over cosine, so it might be easier to go from the right to the left. Well, in this case, I'm just going to try left to right. It really doesn't make any difference. Both of them will have equal amount of steps and to me have the same difficulty level, but I'm just going to start with the left in this case. So, but I don't know where to start with. So off to the side, I am going to imagine what this looks like in sines and cosines. The tangent of A is sine of A over cosine of A. The tangent of B is sine of B over cosine of B. The bottom, 1 minus, tangent is sine of A over cosine of A, and then tangent of B is sine of B over cosine of B. So I see something very common in the numerator and denominator on the right side that I don't see on the left side, and that is a denominator of cosine A and cosine B spread throughout here. So what I'm going to do, I'm going to take the original function and I'm going to create a denominator. I know, Miss Larson, you're crazy. Why would you ever want to create a denominator? Well, in this case, I need one because the right side has a denominator that's just kind of hidden. What I'm going to do is I'm going to multiply by 1 over cosine A cosine B in both the numerator and denominator. So I am giving a denominator to everything. So now this first term in the numerator will be sine of A cosine B, now over cosine A cosine B. The second term in the numerator will be cosine A sine B over cosine A cosine B. That's B. And then in the denominator, the left term, cosine A cosine B, will now be over cosine A cosine B minus the right term in the denominator, sine A, sine B, will now be over cosine A, cosine B. So I gave each and every term the same common denominator. Now let's see what happens. Cosine B's cancel out here. Cosine A's cancel out here. Cosine A's and cosine B's cancel out here. Nothing cancels there. So to simplify, sine A over cosine A is tangent A, plus over here, sine B over cosine B is tangent B. So far, so good. All this cancels, we have 1 minus sine A over cosine A is tangent A, sine B over cosine B is tangent B, which is exactly what I need. So it started out really complicated, but if I just picked apart the end result a little bit, I could see what to do in my first step.